We hope you
You
get
didn't
better.
play it yet.
Yeah, I did. Hi, Gabe.
Say hi, Gabe. Hi, Gabe.
Hi, Gabe. I hope your head is better.
I hope your face doesn't hurt too bad. But it's killing me. Okay.
That was mean.
That was very nice, wasn't it? Okay. So anyway, the binomial theorem, I couldn't resist. X plus y raised to the n. So this is this very scary looking thing, okay, that they have in the book, but you just kind of have to, don't be scared of it. R equals 0 to n, NC, R x to the n minus r, y to the r. So all the binomial theorem is, it's a way of expanding binomials like x plus 3 or something to very high powers. Have you done this before? You've never seen it before. Okay. And why is it in this chapter? Because usually they have it in the chapter where you have factorials and things like that, and probability and stuff like that. NCR. Are you guys familiar with what that means? That's a combination. NCR is a combination of things, and usually that they talk about that in probability. And sometimes they write this NCR. It's the same as writing this, where n goes up here and r goes up here. And NCR is defined as, let me see if I could, n factorial, okay, that's not very good, okay, n factorial over r factorial times n minus r factorial. No one's ever seen that combination before, okay? That's called the combination. And when we get to the probability, a combination is an arrangement of things where the order isn't important, okay? So for example, if you had 10 people and you're choosing a committee of 6 people, how many ways can you make committees, okay? Well, if you have a committee and the order doesn't matter, okay? So you kind of have to divide that. That's different than a permutation. We'll talk about that when we get to the counting section, which is the next section. But just for now, you just need to know how that works. So we'll do an expansion in a minute, but x x to the n minus r, you start with r equals 0. So for example, just real quick to show you what this means, we're going to do an example. If this were x plus 5 raised to the 7th power, okay, then your first term, the first term of that sequence is, or that expansion, is going to be c, n is 7, r starts at 0, okay? X raised to the n minus r, so if n is 7, r is 0, you start at 0 and then you increment up. So it's x to the 0, x to the 7th, y to the 0. So this would be the first term, and we'll talk about how to expand those and stuff. But first we're going to work on how you do combinations by hand. You can do them on your calculator too, but you might very likely have a non-calculator section on your next test, so you should end quiz. So if they say 10C 5, okay, that means 10 factorial over 5 factorial over 5 factorial. Do you guys understand where I got that from?
Yeah.
Right? It's 10 over 5 factorial, and this is 10 minus 5 factorial. Now you can try to reduce that. 10 times 9 times 8 times 7. If I were doing this by hand, this is the way I would do it. Okay? Over 5 factorial. But also, this 5 factorial can be written as 5 times 4 times 3 times 2 times 1. And the reason I'm doing that is because a lot of times you can cancel out things from the top and bottom. That goes away. What else could I cancel out from the top and bottom?
6 and 3.
6 and what?
3.
3.
Well, didn't you say?
Oh,
Oh.
did I forget a 6?
Yeah, you forgot a 6.
Oh, sorry, I forgot a 6. Okay, so this 6 cancels out with that, right?
Mm-hmm.
What does 5 go into?
10.
5 goes into 10 twice, and 4 goes into 8 twice, okay? And see, so now everything on the bottom is gone. See that? And then you just multiply what's left over on the top. So you have 2 times 9, that's 18, times 2 is 36, times 7. Well, maybe there's a better way to multiply those, I don't know. But maybe I go 56 times 2, 112 times 2, which is 224. Is that right? It's correct. 252, they said the answer. What did I do wrong?
Well, there's a 3 on the bottom.
7, oh, I know what I did wrong. 7 times 9 is 63, right? Times 2 is 126, times 2 is 252. So, see what I did? I just like doing math in my head. I don't like punching into a calculator all the time. Okay, so it's kind of a nice way to be able. So you look for things to cancel out everything from the bottom. Everything won't always cancel out, but it makes your life easier. What if I had 8? We're going to write it the other way, just to. So this means 8 combination 2, which means 8 factorial over 2 factorial times what factorial? 6 factorial, which is equal to 8 times 7 times 6 factorial, right? Over 2 factorial, 6 factorial, go away, right? And 2 goes into 8 4 times, so the answer to that is just what?
28.
4 times 7, which is 28. Right? Did I do that right? I did that right. Questions? What if I did 10, or what if I did 8 combination 6? What would that be?
8 factorial.
8 factorial over
6 factorial.
6 factorial,
2
2 factorial. What's that going to be equal to without doing anything?
28.
That's going to be equal to 28 as well, right? Because you have the same thing on bottom, just a different order. Okay? So that's one property of factorials, is that 8 combination 2, so 8 combination 2 is the same as 8 combination 6. Or in letters, so if you have n combination r, that's equal to n combination n minus r. That's what I just did there. You understand? So if the difference between these two is 6, then that 8 combination 6 is the same as 8 combination 2. Same stuff. Same answer. Question on that? You guys want to try one? See what you get? Why don't you try one by hand? Let's do this. 12 combination. Make it, let's see, 12 combination 2. Okay? 12 combination 2. Who's got it? What do you get there, Jess? 60. Is it right?
Yeah.
So that would be, I don't know. That'd be 12 factorial over 12 factorial, not 12 factorial, 2 factorial, 10 factorial, right?
Yeah.
2 factorial, 10 factorial. That's 12 times 11 times 10 factorial over 2 factorial, 10 factorial, which is 66. Go, girl. Okay. All right. So that's how you do factorial. The other thing besides that one property, by definition, well, you can figure out why this is true, but NCN is equal to 1, and also NC0, just because it makes things work, okay? NC0 is also equal to 1, all right? And all of these numbers can be found in something special in Pascal's triangle. Do you know Pascal's triangle? Okay. So Pascal's triangle, it looks like this. 1, 1, 1. You've seen this before. 1, what goes here? 2. So you add together the top two numbers to get the next thing, and it's all ones on the outside. So this is 1, 3, 3, 1, 1, 4, 6, 4, 1. Let's keep going a couple more. 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. If you kept going, okay, this is called the zeroth row. I guess the zeroth row, and this is called the zeroth column. Okay, so going down, the ones is always the 0 column, so this would be first column, second column, third column. Watch this. If I did 5 combination 2, okay, and I go down to the 5th row, second column, 1, or that 0, 1, 2, 3, 4, 5, second column, so this is the 0th column, 1, 2. Okay, so this is row 5, column 2. Row 5, column 2. 5 combination 2 is 5 factorial over 2 factorial, 3 factorial, which is 5 times 4 times 3 factorial over 2 factorial with, over 2 factorial, 3 factorial, which is equal to what? 10. Okay? So when you're doing, if you don't know how to do that, I mean, you wouldn't want to count up to the 20 factorial, 3 factorial, but all of these combinations can be found in Pascal's triangle. These are also the coefficients. So if I were doing something like x plus, this is the 5th row. So if I did x plus 3 raised to the 6th power, these would be the coefficients of each term, okay, when we're doing binomial theorem. But we're going to do it with combinations first, and then if you want to do that, okay? So how does that binomial theorem work? I think I'm going to take a picture of it because I don't want to, let's see if I can do this. I got to take a picture of it because I don't want to write that thing again. How do I do this? There we go. So, high tech. So anyway, say they tell you to expand. Ooh, I'm getting busy looking at that split. that's it's green there. Expand x plus 2 raised to the 4th. Okay? So what you don't want to do is multiply x plus 2 times x plus 2 times x plus 2. Because that's going to probably make mistakes and stuff like that. You could always do that if you get stuck, but it's probably going to take you a long time. Okay, so if I want to expand this, my first term is 4 combination 0, okay, times x raised to the n minus r, which is what? If I start at 0, where do I go to? 4, okay. Y, or 2, which in this case is y, raised to the 0. Okay?
How do you find R?
R is R is incrementing up. Okay, so R starts at 0 and it goes up until you get to n.
So will R always
Okay.
be 0?
R always starts at 0. Okay, so your next term is going to be 4 combination 1 x. This number, R goes up, so this number goes down, and this goes up to 1. Okay, the next term is going to be 4 combination 2 x squared 2 to the 2. The next term is going to be 4 combination 3 x to the 2, x to the 1, sorry, x to the 1, 2 to the 3, right? And the last term is going to be 4 combination 4 x to the what?
0.
X to the, whoops, x, now I don't know how to get back. X to the 0, do you guys know how to get back? What does this do? What? Square. This, thank you. Okay. X to the 0, 2 to the 4. Alright? Now, doing some math, anything, combination, 4 combination anything is, or 0, n combination 0 is always what? 1. So this quantity is always 1. And so this first term is just going to be what? X to the 4. Anything combination 1, did I talk about that?
Yes, 1.
Is always, that's equal to 4. Okay? So this is 4. X to the 3 times 2. We'll worry about simplifying that in a minute. 4 combination 2 is, you can look at your Pascal's triangle. You can do it here. 4C2 is 4 times 3 divided by 2 factorial, right? Which is 6. Okay? And times x squared times 4, which is 2 to the 2nd. The next term is 4 combination 3, which would be the same as 4 combination 1. Remember that rule? Okay? So what's 4 combination 3? It's the same as this, because this is 4 combination 1, so 4 combination 4 minus 1 is the same. Okay, so this is also 4x to the x times 8. And this is just anything combination, anything is just 1. So you get plus 2 to the 4th, which is 16. And then you simplify that. Okay? Okay? Here, we're not playing chess right now. All right, so this is x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. See, so that's better than multiplying x plus 1. What? Did I mess up? I don't think that's right. Okay? The other thing, you can do combinations on your calculator. You know how to do that?
No.
You want me to show you?
Wait one second.
Okay. You'll be able, if it's calculator part of the test, even the scientific calculators have combinations on them. So So if I wanted, for instance, 4 combination 2, I just go 4. Then I go math, I think. And then this is found in the PRB for probability. And there it is, NCR, so you go down to number 3. And then you put in 4 combination 2, which gives you 6. Okay? So that's how you do it. And the scientific ones work pretty much the same. Questions? All right. Now, that's pretty easy, but it gets a little trickier when you have a term over here that is not just X or Y or 3 or 2 or something like that. For instance, they'll say expand 2x plus 3, little bit harder, 2x plus 3 raised to the 5th power. Okay? So I'm going to start with 5 combination 0, right? 5 combination 0, and then what do I do then? 2x, the entire thing. So it's 2x quantity raised to the 5th. Okay, so you can't forget to do that. Otherwise, you're not going to get 2 to the 5th in there. Okay, times 3 raised to the 0. Plus 5 combination 1 times 2x to the 2x quantity to the 4th times 3 to the 1. Okay, plus 5 combination 2. 2x to the 3rd, 3 raised to the 2. Notice that the exponents of my terms, these two exponents always have to add up to that exponent for every term, right? Okay? So the degree of each term is the same as the degree of the polynomial. Okay? Well, not really. I mean the degree before I multiply out all that stuff. And then you go dot, dot, dot until I get to 5 combination 5, 2x raised to the 0, 3 raised to the 5. And do I need to go through and show you how to multiply all that out, or could you do that? Do you want me to? I could just write what the answer is. If you did all that out, you would end up getting 32x to the 5th plus 240x to the 4th plus 720x to the 3rd plus 1080x to the 2nd plus 810x plus 243. So if you did all that out, that's what you'd get. So you would have to, in this case, say in this case it'd be 8, right? X to the 3rd times 9, which times a combination 5 combination 2. Okay? And you multiply. Yes, ma'am.
For 5C0, would the answer be the solution?
5C0, no. Anything C0 is 1.
It's just
By definition, just makes it 1. And anything, combination, anything, like if it's the same thing, it's also 1. So when you get to the end, this thing is also 1. Okay? But just to be consistent, that's what. Right. Okay. Then they'll give you something like this. Find the coefficients of x to the 8th in x squared plus 2 raised to the 12th power. Could you do that without expanding the whole thing? So if you had an x to the 8 up there, okay, so really what you're going to find is some term. So the first term, so if I have x to the 8, what do I have before what would this have to be raised to? The fourth power, right? Understand that? And I'd rather do this than give you a formula for it. Do you understand why that would be to the fourth power? What would the 2 therefore have to be raised to? To the 8th power, because these two always have to add up to that. You understand that? Okay? So I'd have x to the 2 to the 4th times 8, and then I have to figure out what my combination is. So it's going to be combination of 12, and this number always goes with, it's always, wait, it starts at 0, and it goes up to 8. So this number and this number are always the same, right? And so that would be an 8 down there. You understand? Okay? So that this part of it is always the same as this. So if you count from 0, this would really be the 9th term in that expansion, because you start with the 0th term, and then you go 0, 1, 2, 3, 4, 5, 6, 7, 8. So it'd really be the 0. So if I did all that out, they're just looking for the coefficient. So you would have to go 2 to the 8th times 12 combination 8. And if you did that on your calculator, you get that that is equal to 126,720 if I expanded that all out. Okay? Do you follow what I just did? And one more thing, and then I'll do that. Okay? You want to write that down, or we're good? Okay. The last thing says find the find the 5th term and the expansion of 2x minus 3y, 2x minus 3y raised to the 10th, okay? So again, what you don't want to do is expand out the whole thing from 0 up to the 11th term, or yeah, it would be 0, you'd have 11 terms, right? Because you start with 0 and you go to when this is 10. So you don't want to go to the 11th term. So you know that it's going to have a 2x. So if it's the 5th term, what would the 2x be raised to? Not the 5th. It starts at, it starts at, 2x would start at 5, right? And then, so the 5th term, it'll be 10 minus,
2x.
excuse me, it started at 10, right?
Yeah.
So the 5th term would be 10,
6.
10, it would be 6, right? Because the 0th term, the exponent would be 10, right? Understand that?
Yeah.
Sort of. Yes? That's right. Okay? Or you could think of it backwards, and this negative 3y is going to start at 0, and it's going to be 1 less than whatever the term is, right? So that's kind of an easy way to think about it. And then it's going to be 10 combination of 4 in front, because this and this have to be the same. So then you could do that. Let's actually find the term. So you have 10 combination 4. I don't know, let's use a calculator. This comes out to be really big. 10 combination 4 is 10, 210? Yes, okay. So I have 210. 2 to the 6th is, how much?
64.
64. X has to be raised to the 6th. 3 to the 4 is negative, no, it's positive, okay? Positive 81, and y to the 4th. And so if you multiply that all out, you get a big number. Do you get a big number?
Mm-hmm.
What do you get?
10888640 x to the 6 y to the 4.
1, 0, 2 8s.
Yeah.
So you get, is that what that I have? That's what I have. X to the 6th, y to the 4th. So probably you wouldn't want to multiply this times itself 10 times because you'd have to find all those terms. So this is a nice quick way to do it. Okay? Questions on binomial theorem? Pretty easy. It's just kind of plug and chug. But I wouldn't. I used to give this formula like this is the r term, r minus 1th term or something like that. Anyway.
Why did you do it 2x to the 6th?
2x to the 6th because if it's the 5th term, right? Then this exponent, this starts at 0, right? So this up here is always 1 less than the term. And these two together always have to add up to the degree. Okay, so that's got to be to the 6th. Or I could count down from 10 and see what the 5th term is, right? 10 minus 5 plus 1 would give you this, or something like that. Or just, anyway. Okay, so your homework is, what is your homework? I made it. Page 604. Binomial theorem. So counting principle we'll do on Monday. We'll figure out that assignment. Look, this isn't that bad. That's because I made it. I'm Mr. Beamer. But we've been trading to